For our next lesson, we're going to be looking at Module 11, Angle Relationships in Triangles, and we're skipping over Module 11, Lesson 1 for now. If we have time, we'll come back to that later. But for 11.2, we're looking at angle theorems for triangles. And our goal for this lesson is to learn angle relationships for triangles and how to find the missing measure of an angle. Now we see the word theorem in the title for our lesson. Theorem is kind of a fancy word for definition, so we're going to be starting off with a theorem regarding the interior angles of a triangle, which says the sum of the interior angles of a triangle is 180 degrees. So what that means is you find the measure of two angles of a triangle. You can find the third angle by subtracting the sum of the other two from 180. Let's take a look at some examples. For our first example, we're told to find the missing angle measure. So we can see right here that our missing angle is represented by the letter X. We have angle L has a measure of 104 degrees. Angle N has a measure of 57 degrees. And so we're trying to find the measure of angle M, which is represented by X. Now from our theorem, we know that the sum of these three angles together must equal 180 degrees. So this 104 plus this 57 plus this X must equal 180 degrees. So based on that, we can write an equation where we have 104 plus 57 plus X equals 180. So from here, we're going to go ahead and combine our like terms, which are 104 and 57. And when we add those together, we get 161 plus X equals 180. Our next step then is to subtract the 161 from both sides, giving us a value of X is equal to 19. So what that tells us is that the measure of angle M, and that's the notation that we use, measure of angle M is going to be equal to 19 degrees. For our next example, we're again told to find the measure of the missing angle, and we're told that the measure of angle C is 33 degrees. We're told that here. We're trying to find the measure of angle A, which is represented by the letter Y. And then for angle B, all we're given is this box in the corner. Anytime you see this box in the corner of an angle, that will tell us that that is a 90-degree angle. So this angle here is 90 degrees. So again, we have two of the missing measures, or we have two of the angle measures. We have this one is 90 degrees, angle C is 33, so we can use that information to write our equation. So we have 90 plus 33 plus y is going to give us 180 degrees. Just like before, we go ahead and combine like terms. We're going to combine 90 and 33 to get 123 plus y equals 180. Next step is going to be to subtract 123 from both sides. And when we do that, we're going to get y is equal to 57. So that tells us that the measure of angle A is going to be 57 degrees. So those are a couple quick examples on finding the missing interior angle measure of a triangle. Now we're going to spend some time looking at what is called exterior angles of a triangle with our second theorem. Libbity-bibbity. Before we get to our next theorem, we need to go over a little bit of terminology, some definitions. So our first definition is for what are called interior angles, and those are the angles formed by two sides of a triangle. So we have angle D is an interior angle formed by these two sides here. We also have angle E, which is interior, formed by these two sides here, and angle F formed by these two sides here. So angles D, E, and F are all interior angles. Our next term is for what are called exterior angles, and that is the angle formed by a side and the extension of another side. So I only drew one of them. There's actually 6 exterior angles for a triangle. I only drew this one here. So we have a side, and then we have the extension of another side. Okay, so here's the side, here's the extension of the other side, forming angle G. We go over those two definitions for interior and exterior angles to then highlight what are called remote interior angles. And for a remote interior angle, it's going to be the two interior angles that are not adjacent to an exterior angle. So here we said before that angle G is our exterior angle. Okay? So angle F is adjacent to angle G. Angle F plus angle G is going to equal 180 degrees because it forms a straight line. The remote interior angles are going to be angles D and E. So angle G is the exterior angle. The remote interior angles for angle G are going to be angles D and E. Again, the two interior angles that are not adjacent to an exterior angle. These two angles here are not adjacent to angle G, so those are called remote interior angles. So all that terminology, all those definitions to bring us to our theorem, which says the measure of an exterior angle is equal to the sum of the remote interior angles. Let's take a look at a couple examples of this theorem in practice. For our third example, we're told to find the measure of the missing angle, and we'll see that we're given two angle measures here. This obtuse angle here is 113 degrees. This acute angle here is 28 degrees, and we're given this exterior angle here represented by the letter Z. Now the theorem tells us that the measure of an exterior angle, again that's Z, is equal to the sum of the remote interior angles. So we're going to find the sum of these two angles, and that should equal the measure of angle Z. So to find the measure of angle Z, it's simply a matter of 113 plus 28 equals Z. This here is the sum of the remote interior angles. This is the measure of the exterior angles, and so we add these together to find this angle. So when we add 113 and 28 together, we're going to get 141 equals Z. So to write our answer, we would say that the measure of angle Z is equal to 141 degrees. Alright, and for our last example, we're again told to find the measure of the missing angle. So in this one, we're given the measure of the exterior angle. We're also given the measure of this angle here. We recall that anytime that there's a box in the corner of an angle, that tells us that that angle measures 90 degrees. And we're asked to find the measure of, in this case, the measure of angle J. So the way we set up our equation, it's going to be 90 plus J is equal to 125. Show our work. We subtract 90 from each side. These cancel. We get J is equal to 35. So our answer then is going to be the measure of angle J equals 35 degrees. That concludes our lesson on 11.2, angle theorems for triangles. Hopefully at this point you're able to understand angle relationships for triangles and how to find the measure of a missing angle. Any questions? Write them down and we can go over them together in class.